please welcome to the stage Zachary Gearson with Foley Hoag.
Good morning, everyone. Thank you, Josh, for getting us started. I'm really excited to be part of this and to hear the conversations that are going to happen throughout the day today. We have two amazing panelists, and I want to let them introduce themselves before we jump into things, because this is a very timely topic, but we don't have a ton of time. So would you two please introduce yourselves quickly?
Sure. Lisa Salmore. I am the Vice President of Asset Management and Engineering at National Grid. My team covers all of the system studies and engineering that we do for the electric network in New England.
And I'm Mike Phillips. I'm the CEO and one of the founders of a company called Sense. We're about 100 people based in Central Square here in Cambridge, are making software and intelligence for the latest generation of smart meters and working closely with National Grid.
Thank you both. Mike, I'm gonna start with you. Can you set the stage for us? Can you describe what we mean when we're talking about grid modernization or the future grid and why it's an important conversation to be having right now?
Yeah, so thank you. And yeah, if you're wondering why are we starting a climate tech conference talking about the grid, well, it turns out the grid is super important for enabling the energy transition. I think we all know that we have to decarbonize the entire world economy. Energy is about 70% of greenhouse gas emissions, and the pathways become really clear, which is electrify as many things as we can and then decarbonize the electric grid. And so how do we do that? With more and more loads like EVs and heat pumps and more renewable supplies that have this awkward problem that you can't control the timing, the supply and demand mismatch is just becoming more and more important. And look, the grid is an amazing thing, able to do that today, but it's getting harder with all these new loads. And our view is by making the grid smarter, we can go much farther down that path.
Thanks, Mike. And so Lisa, a similar kind of setting the stage question for you, but from the utility perspective. How do you see this moment in terms of what we can do with the grid to benefit customers, and what do you see as the most important opportunities and challenges?
Yeah, so this is an extremely exciting time to be in the energy network. The energy system that we've relied on for decades now needs to be fundamentally reshaped to accommodate electrification, distributed energy resources, and also enhance resilience in the face of climate change. So this is super exciting and a lot of work ahead of us. And how do we do that? We do that by modernizing the grid. And when I speak about modernization, it's around building a resilient network, so a network that's fit for the future. So every time we touch an asset, we replace an asset, it's built for the future. So it's built for the changing climate. It's built for our future policies around electrification. And when I talk about flexibility, it's how do we optimize the grid that we have today? So how do we make the most out of it by making it smarter, by introducing sensors and other great technologies so we can get the most out of what we have today, so we don't actually have to build out as much. One of the challenges is when I take a step back and between the infrastructure builds, between the software, the innovation that we want to deploy, that's a ton of work ahead of us. And so one of the biggest challenges that we're working at is how do we do this at pace, and how do we do this fast enough to modernize the grid for our customers? And that's where the opportunity lies with our collaborators, with the partnerships, with the innovators to help us along the way.
So I'm going to just keep us on that direction, going from the big high level, what are we talking about, to more specifically, what are we doing in Massachusetts, and what are we doing in Massachusetts that's most exciting to you?
Yes, so look, I've been on a bit of a mission to make utility meters cool. I would say cool again. I don't think they were ever cool, though. But we keep talking about the smart grid in a general way. But look, at the very edge of the grid is these guys. I brought one of them with me. The latest meters now have little computers inside of them that can run software, and we're writing AI models running on these meters to give consumers visibility into energy in their home, help them manage energy, and have visibility into the grid at the same time from the edge. And look, it's very analogous to what happened in the telecom world. I used to work on voice assistants on mobile phones, and a while ago, a phone was just a phone, and then it became a little computer that you could run software on, and basically completely transformed the telecom industry just based on that little fact. And the same can and should happen on these utility meters, so again, making them cool, making it so for the first time ever, consumers would look forward to the new meter getting installed in their home. I don't think that's ever happened before, but it's gonna. And look, we can talk more, but we've been doing really interesting work with National Grid, and Massachusetts is leading that charge.
Maybe people would line up for new meters if they came in brighter color choices.
Yeah, as well.
But I want to take that to you, Lisa, from the utility perspective and the National Grid perspective specifically. Where are you in terms of these newer meters, the advanced meters, and how does that fit into more broadly what you are doing, the types of sensors and other things you talked about deploying on the system?
Yeah, so I think we've deployed over 30,000 meters so far, and we're going to deploy over 1 million over the next few years. And it gives customers just a great insights on how they're using their electric usage. At National Grid, we're excited about building resilience into the network and flexibility, and leveraging sensors and data and software so we can optimize and make a smarter network, a network that can adapt to what's connecting and what's happening on the system. One thing that we've been deploying across our network is what we call self-healing network. So it's a series of sensors and automatic devices and logic. So if a tree falls on a line and creates a fault, these sensors can identify where it's happening, isolate it, and then begin a series of switching to restore as many customers as possible. Now, we have this on about 20% of our network right now. And since we started a few years ago, we've avoided over 30 million customer outage minutes. So if you could imagine, once that's deployed on our whole network on an annual basis during every storm event, the more reliable our system is, the better for our customers. So I'm super excited about all of the technology, the sensors, the data that can help us make better decisions and help automate our network.
And is there a link between the new advanced meters and those other capabilities, or are they independent?
So I'll start. I know, Mike, you'll add in. There's a huge opportunity because it's all about the eyes and the ears on the network and feeding that data back to our control centers to make those right decisions. And something like the advanced meters and the software and the computers that are in them, they can be more eyes and ears that are distributed across our network at the edge that can give us even more insights. So we just talked about this last week. I'm super excited about continuing collaboration to test that out and see how we can improve how intelligent our system is by the information coming from the meters.
Yeah, and look, I want to add, because it's a really important point, especially in the context of climate tech here in Massachusetts, that National Grid really has led this. We started working with them some years ago about how next generation meters could support these needs. It was quite advanced thinking in the early days. And these are now getting deployed first in New York and now Massachusetts. And this has now become kind of the entire industry is now looking at this. It's now called AMI 2.0. Because of the timing of this is happening first here in the Northeast. I'm spending a lot of time in California because they're now looking at their next generation meters, but it'll be another 5 years before they start to deploy them. And we're also looking worldwide. We have a bunch of folks in Japan that keep coming to visit, asking what's happening at National Grid. So worldwide, this notion of making meters smarter is super important, being led by this effort. So back to Lisa's point, these are now just getting rolled out, and we're going to be doing a lot of work and I think not just us, but this notion that these advanced meters are out there that can run software and applications. There's so many opportunities that we should collectively work to unlock.
So mentioned resiliency, reliability, and some of these other benefits associated with this new technology, but I want to make sure that we focus on affordability as well, because I think, you know, when we talk about energy, affordability is always an incredibly important priority, and it just seems to become more so and more so. So could either of you talk about how advanced meters or these other technologies are opening up opportunities to provide affordability benefits for customers?
Yeah, so look, there's some very direct benefits to the consumers because they can use these applications available on meters to help them save energy. People can track down where they're wasting energy. They can see how there's bills tracking in a real-time way to see how they can get direct savings for themselves. But more importantly, this notion of going from hardware-based solutions where the way to deal with more and more renewables, more and more EVs is just build more poles and wires. If you start to make things smart, you can reduce the need for massive infrastructure changes by making the loads more flexible. This load flexibility ends up being the key part of how we can use more intelligence at the edge of the grid to better manage that there's 3 EVs trying to charge at the same time. Let's make them take turns and not have to upgrade the transformers.
Yeah, and the meters unlock the opportunity for different pricing models, so time of use rates. So then customers can make decisions. When do they want to charge their EV vehicles? When do they want to run their electric dryer based off of rates? So that's a huge advantage of the meters. And then depending on the flexibility, depending on how we use the distributed energy resources across the network, that does have the opportunity to extend the time in which we then need to do an upgrade because of load growth. So it's all the upgrades we need to do in the system is driven by load growth. So to the extent we can optimize the grid, optimize usage of the network, we could potentially delay some of those upgrades that are needed.
Thank you. There are some pieces in there that I'm going to definitely try and follow up on. But the first one that jumped out to me as someone who lives in the regulatory side of this world quite a bit is that when we talk about getting new technologies or innovation out on the grid, there are kind of 2 sides to it. There's the technology or the solution and does it work? And then there's a regulatory policy. Can we make the rules allow for, support, encourage this type of development? So I want to give you both the opportunity to either comment on that or push in the other direction, but also to point out any ways in which you think Massachusetts has been successful with aligning regulatory policy to support technological innovation and advancement, or perhaps the reverse challenges.
Yeah. So, so there's a couple programs that we have. So the AMI meter, right? That was a specific filing, right? That we worked with the regulators in Massachusetts to get passed, and now executing on. A few years back, we had the grid modernization plan, which was again another policy-driven filing that we had, and that was the beginning of our ability to invest in that self-healing network that I talked about a few moments ago. Currently, we have the electric sector modernization plan, and in that filing, there's a proposal for grid services compensation fund, which actually compensates customers to use their distributed energy resources to benefit the grid. So that's actually providing the compensation and the dollars to make it actually happen and incentivize people to optimize how the grid's being used.
Yeah, so certainly the combination of policy, regulatory, utilities, and technology all have to come together to make this happen. And look, Massachusetts has been really unique in doing that. You'll be hearing from the governor here in a sec. It seems like the overall goal around efficiency, decarbonization, commitments to the climate goals are strong, while working on how to handle affordability is driving a lot of this. And look, I think we see those dynamics in some other states, but Massachusetts has enough scale to matter, and we can really lead these things without being so complicated that you can't get anything done. Again, I'm spending a lot of time in California, and boy, is it complicated there. It's kind of the same dynamic, but really, really difficult to navigate. Not just for small companies like us, but for the entire industry. They can't build things because of interveners, not in my backyard, but they know they need to meet the transitions. I think, again, Massachusetts has brought this together in a really great way that it's just been a great place to innovate here.
Well, I like the message that the years in working groups and processes are potentially paying off in Massachusetts. So I think that's personally heartening for me. I want to drill down a bit on something you were saying, Mike. I think the analogy to getting computers into phones is a really compelling one. And the idea of a transition from hardware to software is also compelling when we think of the electric grid. I think most of us think about the wires that we see, the substation you may drive by, the transformer and I'd like if you could just talk more about what you mean by that transition, what's required to make it a successful transition, and then what benefits we get at the end if we can successfully make that transition.
Yeah, I mean, certainly the investments in the grid in the past have been mainly hardware assets, or the older meters had some sort of software in them, but it was fixed. You couldn't change it. And look, we don't know everything about what needs to happen in the next 20 years to enable the energy transition, but we do know it has to happen in that time frame. So if we tried to predict right now all the kind of capabilities we need in the grid, it would be hard to do right now. And if we had to have fixed assets to deal with it, it's just going to be tough. If you can instead get the right platforms out there, so this can now be software. Once you get these latest meters, you can upgrade them for the next 20 years with new software, new capabilities, better load control, better consumer interaction. So getting that right as a platform first, and then ability to upgrade and download software over time, we think is just a key starting point.
And I want to follow up, Mike, quickly, because we've been talking about the meters, and I'm not sure you have conveyed yet how cool these cool meters are. And I want to give you an opportunity to just talk about what these meters can really do for a customer.
Look, so the previous generation, even smart meters, the so-called AMI 1.0, were basically just data collection devices. Consumers have had to manage their energy by getting a bill at the end of the month, or maybe something that says how you compare to your neighbors. Then you had like this, they're called 15-minute interval data. You'd get a reading from the meter every 15 minutes, goes to the utility hours later. But how could you make that useful to consumers? There was a theory you could make useful consumer apps, but look, consumers only care about what's happening right now. So the latest meters now can process data in real time. They can have connectivity into Wi-Fi, so you can look in your home and you open an app and see what's happening right now in your home. That real-time notion of you just hit a new peak, something's happening in your home, you can go see what's happening there right now is super important for the consumer. The analogy I use sometimes is like, imagine if the way Google Maps on your phone worked is that your phone would send 15-minute interval data of your location to Verizon, who would make it available to Google Maps the next day. Like, what would Google Maps be? It'd be like a static map and a report of traffic on your route, comparing to your neighbors once a month. Like, how would you use that? You would not use that. So, like, getting this notion that these are really dynamic, real-time things is key to unlocking this stuff.
And so, Lisa, I want to ask, thanks, Mike. For me, that's exciting. And I think potentially for others as well, and we'll find out in the future. But Lisa, I want to give you a chance to broaden that discussion away from the meters. I think it's almost a cliche these days that the electric system is going to be asked to do all these new things and provide new services. And I want to give you a chance to explain why that's cool, how that will benefit people, and kind of a little bit more detail about what that might mean for people.
Yeah, so I do want to note a critical aspect of what we're talking about, whether it's sensors, meters, it's communication. communication lines. So we're investing in a lot of upgrades and installations of communication. So our system can talk and we can see what's happening. So I did want to make that note of how important the communication, the fiber, the radio system is so important to how we operate the network and make it smarter and tie in all these parts and pieces. We have also been deploying using predictive analytics. So based on the sensor and the data that's coming in, using predictive analytics to make decisions ahead of time. So what we're talking about is more reactive. You're seeing real time what's happening, and you're reacting to that. But these predictive analytic worlds where we can actually begin to identify issues on the system, and we can send crews out ahead of time to address that issue before it becomes an outage. So all this technology, the sensors, the communication, it just shows up in so many ways for benefits for customers, whether it's how they're using their energy and lowering their bills or the reliability of the network day in and day out.
Thank you both. I've really enjoyed this conversation. Did we just get more time? That would be fabulous. I guess I won't give you a last question. I'll give you a kind of a penultimate question. So I'm going to shift the focus a little bit for this kind of next set of questions. And so, Mike, I want to draw on the opportunity we have to talk to you as an innovator in the technology space who's gone from an idea to something that's now being deployed. And if you were going to give advice to other folks who have ideas or something on a drawing board about what's most important to get from that stage to get to the stage where in this incredibly complicated electric system you can actually have things deployed out there, what would you tell those folks who may be in the audience today?
Yeah, look, I mean, myself and many people from the tech world are like realizing they should spend their time working on things that matter more. So there's a number of people that kind of came out of the tech world and figure out, like, let's work in the energy space. And frankly, it's tough. It takes a while to learn about the complexities of not the technical bits, that's pretty clear, but the complexities of the, as you mentioned, the regulatory, policy, utility world is super important to get all that right, to figure out how do you navigate that space. So I think maybe one bit of advice is to take that part seriously. And again, coming back to the theme of the conference, I think the progress we're making in Massachusetts, where events like this, events like all those workshops you're talking about, I think is setting the framework to allow much more innovation in this space. And maybe just one more thing to add, that there's something that tends to happen in the tech world, which there tends to be clusters of companies. There's already been a huge cluster here in Massachusetts around biotech that we all know about. There's been in my previous career, there's a cluster around voice systems, speech recognition, and so on that developed a little cluster here. And I think there's really the opportunity and a lot of intentionality to make a cluster of that around climate tech, and I'm very supportive of that.
Thanks, Mike. And Lisa, I want to ask a similar question to you, and I think this will be our last question. And that is, so you have the perspective of being kind of on the end of that process. You're responsible for a distribution system and making sure that it stays safe and reliable. You see people, I assume, who have ideas and want to get them deployed out there. What is it that you're looking for? What should they be focused on to get from an idea to a point where you can actually say, I want to investigate that, or I want to get that out on the grid?
Yeah, I think the number one recommendation is early engagement and communication. There's some challenges that I've seen around new technology and integrating it into existing systems, or cybersecurity risks, or our constant challenge with outdated or inaccurate data. And those are often some challenges that we're working through. They're not unachievable. Like we can work around those challenges, but when innovators come to us early and often and have those conversations, and they understand the day-to-day challenges that we have, they can help adapt. They can help us with those challenges, and they can integrate some of the solutions that we can overcome those challenges together with. So early collaboration is key.
Turns out talking together is important. So thank you both. That was a wonderful conversation. I really appreciated the opportunity to talk with you. And so could we give a round of applause, thank our panelists?